scheduling algorithm example solution. So here in this presentation we will look about four primary CPU scheduling algorithms, mainly are of first come first serve, shortest job first, priority scheduling, and round robin scheduling algorithm. So we'll see how each algorithm works. So the given problem here is like the there are given been 5 processes with burst times and priorities. So we need to calculate the completion time, turnaround time, and waiting time for these things. So when it comes to the formulas, we have completion time, which is the time at which the process completes its execution, and turnaround time is the total time taken to from the arrival to the completion of the process. So to get the turnaround time, we need to subtract arrival time from the completion time. So generally arrival time is assumed to be 0 here. So the waiting time is the time where the burst time is removed from the turnaround time. Then we will get the waiting time. So then we will compute after computing the turnaround time and waiting times, we will compute the averages of those things. So here the first one is first come first serve. So initially we will compute the completion times of everything. So here are the 5 processes completion times, which is we have the first with 10 millisecond, and the second one with 15 millisecond, and third one with 23 millisecond, and fourth one with 29, and fifth one in 31 milliseconds. So these are the completion times. So we keep the completion times here along with the burst times. So now we are calculating the turnaround time, because we kept in this order because it is a first come first serve. So in this scenario we have 5 process. So in this 5 process, P1 is first come, and then we have P2, then P3, P4, and P5. So to calculate the turnaround time, we will remove the burst time from the, we will remove the arrival time from the completion time. So 10 minus 0, 10, 15 minus 0, 15, 23 minus 0, 23, 29 minus 0, 29, 31 minus 0, 31. So the waiting time, the waiting time is nothing but the turnaround time minus burst time. So 10 minus 10, 0, 15 minus 5, 10, 23 minus 8, 15, 29 minus 6, 23, 31 minus 2, 29. So we have got the waiting times and the turnaround times of each and every process. Now we are going to calculate the average time and the average waiting time. So here we got 21.6 millisecond of the turnaround time average, and 15.4 millisecond of waiting time average. Second one is shortest job first scheduling. So here the process with shortest burst time are prioritized. That means whichever process having the shortest burst time. So here the process 5 is having the 2 burst time, which is the shortest of all the 5 process. So now we are taking from smaller burst time to the largest burst time. So according to that, process 5, process 2, process 4, process 3, and process 1. So similarly we will have the completion times of this one, and then we will calculate the turnaround time and the waiting times, and the average turnaround time here is 14.8 millisecond, and average waiting time is 8.6 milliseconds. So here the completion time, you can see the first process completion time is 2. After that, to get this 7, the completion time is 5 plus 2, which is 7. Then 13 we got the completion time 6 plus 7. That means combination of P5, P2, and P4 gives us a combination completion time of P4 here. So like that, similarly we will get the P3 and P1. Next one is the third one, priority scheduling. So it is set of the highest priority given, which is having the lowest number. Okay, so which lowest numbers are executed first. So in the priority scheduling, the priority which is having the highest priority, that is of lowest number, is selected as. If you go back to the question, Here we have given the priority wise. So here the lowest number is 1, which here our priority is process 2, the second priority is P4, the third priority is P1, fourth priority is P3, and fifth priority is P5. So in this order, the burst time is selected depending upon the priority. So that is called as a priority scheduling. So similarly, now we will have the completion time. So first completion time is 5. After that we have 6 plus 5 11. After this 11 plus 10 21. 21 plus 8 29. 29 plus 2 31. So the completion time is calculated here. Then we will calculate the turnaround time and waiting time for this one. So the average turnaround time in the priority scheduling is 19.4 milliseconds, and average waiting time is 13.2 millisecond. Then next we have the fourth one, which is called as a round robin scheduling. So the processes are cycled in order until they complete, with each receiving 4 milliseconds. So the time slice we can consider anything. So here we consider as 4 milliseconds. So below we have been computed how it works. So here it is like complete continuous cycle till the process ends. So for example, we have given of 10 milliseconds for process 1. Now it is using the time slice is given only 4 milliseconds. So 10 minus 4, the remaining time is 6 milliseconds. Now the completion time is 4 milliseconds. And similarly we have second one as 5 millisecond. So 4 millisecond it utilizes, and then the remaining is 1 millisecond. So now 4 plus 4 8. So similarly next one P3, it has 8 millisecond, 4 we have utilized and 4 is remaining. Then it is 12 completion time. Then P4, it has initially it has 6 millisecond, 4 milliseconds have been used in this cycle and 2 milliseconds are remaining. And process 5 has only 2 milliseconds. So now it completes actually. So whatever time it is there, we have to add that to the completion time. So now the process 1 completion time is 4, process 5 completion time is 18. This is one complete cycle. So we are going to the second cycle. So now initially we have P1 with 6 millisecond remaining. Now it uses another 4 millisecond, which in turn we have 2 millisecond. That is of completion time which gives 22. So process 2 we have only 1 millisecond, no need to subtract anything, no need to utilize the time slice. We will directly add that 1 millisecond to the completion time in the process 2. Then we have P3. Similarly, we have 4 millisecond, we utilize those 4 millisecond, and 4 minus 4 is 0, and we have the remaining time 0. Now the completion time is 27 millisecond. And process 4 we have only 2 millisecond, so we cannot utilize 4 millisecond time slice. Then we are directly adding to the completion time of in the second cycle. So now we have 2 milliseconds in the process 1, so we are going to another cycle. So now process 1 in the third cycle also completed. Now we have completion time of 31. So overall now we have for process 1 31 completion time, and for process 2 to complete it take 23 milliseconds. For process 3 it took 27 milliseconds to complete. For process 4 it took 29 milliseconds, and for process 5 it took 18 milliseconds. Because this is completely different from other 3 scheduling algorithms, here we have a time slice. With that time slice, with the cycle rotations we utilize here in the round robin scheduling. After that, we similarly, like previous one, we calculate the turnaround time and the waiting time, and then finally we calculate the average turnaround time and average waiting time. So these are the 4 scheduling algorithms calculated the turnaround time and waiting time when the burst time and the priority time is given. So first come first serve, shortest job first, priority, and the round robin with the particular defined time slice. If time slice is defined, we should perform according to that time slice. If time slice is not mentioned particularly, we can consider whatever time slice we prefer. So there is no standard time slice. If in the question if it is given, we need to follow that queue, that is of time slice. Quantum time they will prefer time slice, something like that. If they didn't mention anything, we can consider whatever time slice we need. Okay, so this is a CPU scheduling algorithms example solution.